Okay, so this is going to be the final video for day 2 of unit 4, and in it we are answering EQ3 right here, which is how can we calculate the measure of each individual angle on a regular polygon. So now we're talking about regular polygons, meaning all the side lengths and the angles are congruent to one another. Okay, so we've already figured out the pattern right here for the interior sums. We're not going to worry about that, and I'm going to have to fix that for when I do the actual lesson. Anyway, how could we figure out what each individual angle is going to measure, right? So the simple way to do that, okay, and I'm going to go ahead and delete these questions because I feel like these are going to throw you off. Because I know a lot of you guys watch this without the sound on and you're just watching the captions. So, okay, so how can we calculate the individual measure of each? Well, let's start here with triangles and see if we can derive a pattern. Okay, so that pattern is really simple. If all three angles are going to be the same, we would just take 180 or pi and just divide by 3. So in degrees, we know all three of these would be 60 degrees. Okay, because 180 divided by 3 is 60. Okay, so no duh, right? What if we were in radians? Well, nothing changes. We would just say pi over 3. Okay, so simple, 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 right? Now we move on to a quadrilateral, what's known as a regular quadrilateral, and we have a name for that. That is simply called a square. Anyway, what do all four angles measure on a regular quadrilateral? Well, let's find out. If there's four angles, right, and they all measure the same thing and they add up to 360 degrees or 2 pi radians, right, we would simply divide 360 by 4 and 2 pi by 4. 360 divided by 4, well, duh, that's 90 degrees, which we already knew that. So all four of these guys would be 90 degrees. Okay, well, what about in radians? Okay, so in radians, we already know a right angle is pi over 2, but I just want to prove a point. I would have 2 pi divided by 4. Okay, well, that of course reduces down to simply pi over 2, and we already know a right angle in radians is just pi over 2. So on a regular quadrilateral, all four angles would be equal to pi over 2. Okay, and if this pattern continues, we get a really simple formula from this. Okay, so that formula, basically, if I want to know, what is the individual angle of some regular polygon, and we're just going to refer to that as theta regular. Okay, so theta regular of some regular polygon with n sides is going to be equal to the interior sum divided by the number of sides. So I sum is the same I sum from the previous video here, this I sum. Okay. And n, of course, is the number of vertices or side lengths. Whoops. I almost put vides. Vertices or sides. Okay. So let's try it. So let's say we have a 12-sided regular polygon, right? And if it's a 12-sided regular polygon, we would call that, what would we call that? A dodecagon, I believe. Yes. Yes, we would call that a dodecagon. Maybe I'm wrong, I don't really care. But a 12-sided regular polygon, okay, so that, if we're going to use the formula, is going to look like this. Okay, so a 12-sided regular polygon, right? So that's equal to the interior sum of a 12-sided regular polygon, all divided by, well, the 12 vertices or 12 side lengths. Okay, so the interior sum for a 12-sided regular polygon can be found by doing the same formula from back here. Whoops, not that one. No, wait, yeah, it is that one. Okay, so all I'm going to do is simply plug into that. So we're going to do simultaneously degrees and radians. So we're going to say 180 degrees times n minus 2, all divided by n. Or another way of saying a half circle is pi times n minus 2, all divided by the number of side lengths again. Right, so we do some quick maths. 12 minus 2 is 10. 10 times 180 is 1800. So we see we have 1800 over 12, right? 1800 over 12 will reduce down to 150 degrees. Okay, so each one of these angles right here, in degrees at least, would be 150 degrees. Okay, or in radians, 12 minus 2 is 10. 10 times pi is 10 pi. Right? And 10 pi over 12, I don't even need a calculator for that. That would just reduce down to 5 pi over 6. Okay, so theta regular would simply be equal to 150 degrees, right? Or if we're in radians, we would say 5 pi over 6 radians. Okay, one more example, just to make sure we've got it. What if we had a 20-sided regular polygon? Okay, so theta regular, here, let me use green first. Theta regular of a 20-sided regular polygon, pretty gnarly. Okay, that's going to be equal to the interior sum. So a half circle times n minus 2 all over the number of vertices, or a half circle in radians this time, times n minus 2 all divided by the number of vertices. Okay, and we'll go ahead and plug in for n. We're going to say, of course, 20. Okay, and I am not going to even attempt to draw that. Like this one has 12 sides here, and it already looks the way it looks. A 20-sided polygon, yeah, you can already kind of use your imagination there. Okay, so if I can just decide what color to use. So 20 minus 2 is 18. 18 times 180, I have no idea. 18 times 180 is 3240. Okay, so that's 3240 degrees, right? And I, of course, forgot to plug in for n here. N is supposed to be 20 down here. Okay, and we divide that by 20. And you can see it's a little bit more arduous, actually, dealing with degrees than it is with radians. I'm actually having to use a calculator, whereas with radians, I'm probably not going to have to. Okay, so 162 degrees. So each one of the angles, each one of the 20 angles on a regular 20-sided polygon would be 162 degrees. Pretty crazy. And then in radians, we would have 18 pi, right? 20 minus 2 is 18. 18 times pi just gives us 18 pi. Over 20, I can easily just reduce that now. That becomes 9 pi over 10. The only time I need to use a calculator for radians is to say, well, what is that? Like, about how many radians is that? Okay, so, well, then, yeah, you do kind of have to use a calculator. So control divide 9, where's the pi button? Really? 9 pi over 10. Okay, so that'd be about 2.83 radians. Okay, so that does it for this video. Really simple stuff to use here. Plugging into formulas is not difficult, and that's a lot of what this unit's going to be about. That's the easy part. The difficult part is finding those things to plug into, and that's going to take trigonometry and algebra and, among other things. That's where all the actual thinking is going to come from. Okay, so if you need any help with any of this, obviously shoot me an email or come and find me. Goodbye.